Hey everyone, in today's video we're going to take a look at this Sencore SG165. Most of you are probably thinking, that's not a stereo, that's not a Marantz, what the heck is this thing? Well, it is a piece of equipment that I'm going to learn how to use so I can do FM alignments on tuners for vintage receivers. This is something I've wanted to be able to do and understand for quite a while, so I'm pretty excited to have purchased this. In part thanks to all of you for watching these videos. So this is a very complete tool. It's got just about everything you need to properly align an FM tuner and an AM tuner. It also doubles as a power meter, so I could take a power amplifier when I'm done with it, or before I start working on it, hook it up to here, and then it'll tell me what the output in watts per channel is on each channel. I'm not going to use this thing for those purposes. I have better tools for that. But it's still cool that it's here, and it makes it look super cool with the big meters on top. This video is not going to be about actually using it. I've already tested this thing. It works mostly. I've been able to get a 400 Hz sound into my tuner and tune to it and hear it. But looking inside of this thing, there's a few things that I'm a little bit concerned about that I want to address before I use it any further. So let's take a look inside of here. Alright, so here it is. Sencore SG165 AM/FM stereo analyzer. We've got modulation, we've got tuning, we've got rocker and microvolt output, all kinds of stuff. We've even got pilot. I'm going to know what all this stuff is later, but for now it's pretty new to me. There's a few things that are very wrong with this piece of equipment. Let's start with the first one. I actually watched an X-Ray Tony B video on this thing after I got it, and I noticed that this right here, I'm just going to have to manually focus here, so there it is. You can see right there, this plastic or nylon shaft is broken, so if you're going to use the RF tuning, not going to work. And the X-Ray Tony B video said this is broken on all of them. So I don't feel too bad about that. This could be fixed pretty easily with a sleeve or something. I'll show you what I do toward the end of this video. But there's another thing that was concerning to me. If we look back here, we've got a little power supply board right here. But let's take a look at this capacitor right here. Look at that little wart looking thing growing on it. That is not good. We do not want that in our piece of test equipment. So I'm going to remove that, we'll test it, see how bad it really is, and install a replacement. So that's what I want to do next. I want to start further taking this thing apart. We're going to remove all the knobs, which come off with little set screws. You can see them right in there, little holes. And then we'll remove the bottom section of this thing, take the cover off of that, and see if there's anything bad inside of there. Alright, let's go. It appears I do not have a small enough, or big enough either, Allen wrench to get these guys off. Looks like it's a 1/16. But I suppose I could still play around back here, so let's get to it. Alright, so there we have a loose power supply board. Let's take a moment and measure some of these capacitors with the old fluke here. This is not the best tool out there for measuring capacitance, but for today it's going to get us by just fine. So let's start at the bottom here. This is supposed to be a 1000 microfarad 35 volt capacitor, so let's see what we have here. In circuit we have 1500. You know, sometimes capacitors can be like up to 50%, so I don't see a tolerance on this, but if I want to be optimistic I could just say that this one is, you know, within spec, I guess. But I don't really know about that. Alright, next up we have a 250 microfarad 15 volt capacitor. Let's see what this guy measures at. So I measured this before and I knew this was going to happen. I'm just kind of surprised that a 250 microfarad capacitor is measuring at 5,000, going back to 3,000. It's a little all over the place here, so let's pull a leg from the circuit board and see if we get a more favorable value here. We got that. And there, see, we just lifted it out by the 1, so now we can get another reading, see if it's any different than the one we got the first time. Okay, yeah, so that's far more in line with what we would want to see. So that's just a good example of sometimes you can test stuff in circuit and it won't read properly, or it'll read really strangely. Always just pull one leg so you can get it out of the circuit and make sure nothing else on here is messing with it, causing it to give a bad reading per se. So here's what I'm gonna do. I'm gonna replace all 4 of them, even if they are good, because they're freaking old and new ones are like $1 each, and I'm about to put in a Mauser order, so I might as well just go for it and get some nice new stuff on here. I know that it's not going to cause me any issues in the future. Well, you all probably saw that. Why didn't you tell me I could just remove it and have it open like this? Come on, guys. So I would really like to see what's going on under this thing, so I'm going to remove some screws and see if I can get there. So let's take a look inside here. This is the RF tuning cap. This may look kind of familiar to you. It's basically looks like a 2-gang tuner or something on a stereo receiver, if you've ever looked inside of one. And that's because that's what that is. It's a tuner capacitor. So that's what changes the frequency at which this thing outputs a signal. And this is a mode selector switch. This could probably be cleaned. There's plenty of capacitors in here, and there's one very big one right here. It's going to be difficult for me to show it, and you can actually see it, but look at that left side. It's like a little wart on that one too. That is stuff leaking out. I'm doing my best here, folks. I'm like standing on my tippy toes trying to get that, but that is not a good sign. Even if that cap checks out as good, I'm still going to replace it because it is visibly leaking. So looks like I've got a little bit of work cut out for me. I will go ahead and get those replaced. Just want to show you real quick. I was measuring that big capacitor in here. It's supposed to be 2,000 microfarad. And when we do this, what do we get? 3,500-ish. Yeah, so not good. Way out of spec. We need to get that thing changed ASAP before we use this anymore. I'm just kind of recapping with what I happen to have on hand. When you see axial capacitors in this old stuff, like this is an axial capacitor because the lead kind of runs along the axis of the cylinder, you can replace it with a radial, whereas like these leads, they run kind of along the radius of the circle. Doesn't really matter. They used these big massive capacitors in the time because that's what there was. I'm sure if they had access to stuff like this where you could fit, a massive capacitance in a pretty small package, they would have done this. But that's not what they had at the time. So all you gotta do is just stretch the leads, make sure you get them right. But one thing I wanted to point out is that, why don't you take a look at C7 right there. Does that look right to you? Guess what? It is. The board was marked incorrectly. Same thing with C4. Take a look at that. We've got the negative going into the positive and the positive going into the negative on the board. So what gives? Well, I looked back at the video and confirmed my memory of I saw this guy right here. This is the old C whatever. Let's call it C7. I remembered seeing this black arrow on this capacitor facing me. So I looked closely. You know what that actually says? That actually says positive. So the positive lead on this thing, facing us, was going into the negative mark on C7. And I confirmed that this is true. I was like, oh, is that actually the positive? Why would they mark it that way? If you look further into this thing, if you look inside, like right here, you can see that, let's look at that one more to the right. I know it's not easy to see, but believe me when I tell you that the lead with those marks, those arrows pointing at it, is going into the positive spot on the circuit board. So that is indeed marking the positive, which is interesting because almost always on electrolytics you mark the negative, like this. Well, that's not the case with these little guys right here, these little 2 microfarad ones. So if you happen to be using this to help yourself rebuild a SG165 power supply, this is how I did it. And make sure you take note of that error in the board. Also, I confirmed this in the schematic too. If you download the service manual, or the instruction manual really, you can look at the schematic and confirm that the traces go to the components they say they go to. I only have one of these in right now because, well, I only have one of them. I've got another one on order. I'll put it back in here when I get it. And hopefully by the time all that stuff gets here, I'll be able to actually remove this thing. We get the correct size Allen key, take those knobs off. We can get to replacing this big guy right here. Don't want that in there anymore. So I got this thing out, and it's kind of goofy how it comes out. Like this whole shaft is just like, in here, so you need to... I didn't think it would happen, but I knew it had to be this way because this is all one stamped piece. You gotta slide it out like that. Unplug all of these, including this, and then you've got yourself this board, which has the tuning cap, if you will. And that's so I can get to these solder joints to replace this guy, because there's our visible leakage right there. So this is old. This is bad. We don't want this in here. So it's kind of funky how they did it. They've got it soldered to the PCB and soldered directly to this RCA jack. So I'll need to make sure I take care of that. Let's take a little close-up of what I did here. The old component had these really long leads, so I cut this one off, and I made a little extension right here that goes from this extended lead here to the RCA, just like it was before. And then this is kind of up here high enough to where it clears this little transistor. This is soldered just as it normally would have been. So I like this. This is a nice replacement for the original leaky capacitor. The next thing I want to do is clean this main switch. This is like the main function or mode switch on the entire thing. So you can see it's got these little plastic guys, but on the inside I see metal on metal contacting. So that means we're going to use deoxit D5 to clean these, and I think that these little tiny holes here are where you would want to spray a little bit. So I've got the knob hooked back up just so I can move this more easily. Now I'll just kind of give a little squirt squirt. There are all these holes here. Of course, probably the most concerning and important thing here is how the heck am I going to fix this broken shaft here? That's something I'd like to know even. So the way you do that is, I don't know. I am sort of lucky in that this thing broke in such a way where it's very obvious where it broke, but I do need to figure out the best way to sleeve this thing. See, here's why they break, folks. See right there? It's hollow, right there. And then it's solid going all the way out here. So, that's why they break. Well, it's the next day, everyone. I went to work and found this little sleeve thing right here in the scrap bin at the machine shop. It was just a little tiny 1/4 inch ID piece of plastic here, and well, it was good enough with some super glue to put this shaft back where it used to be. So now, in theory, I can put these back exactly as they were on the unit over here, and we should have returned functionality of this thing. I replaced these two capacitors right here because when I was measuring with my multimeter, one of them measured like 70 when it was supposed to be 10. I took it out of the circuit and it measured 17, which is, you know, not terrible. But I figured, you know, I've got these, might as well just replace them. They're so easy to get to. And like you saw, we replaced this one already. So I'm going to put this back together and we will see if it works. You know, it's funny, I was plugging these connectors back in and I thought, oh yeah, I've got them right. Let me look back at that picture I took of these to make sure I got them right. I did not get them right. I switched around these two. So it's a good thing I took a picture of how it was connected before I took the unit apart. As you can see, there's our new guy. Mounted in there very nicely, so we got plenty of room for it. Okay. Now that it's back together, I'll get a tuner and a scope and we'll see if we can get this thing to do anything. Okay, so I've got this hooked up a little bit crazy. This is going to be generating a signal. And I've got this cable from the output going into where the FM antenna hooks up. And then I've got my scope connected to the speaker outputs, or speaker B. And I've got actual speakers on speaker A, so let's just turn this on real quick. Make sure we get
experience with Alan.
Okay, so we have
Land controls is a plus. Raymond is offering this one.
Radio signal out of both sides. So now what I'll do is I'll turn on my scope and I'll turn on this thing. Let's turn off the A speakers so we can see in our scope that, you know, we've got actual music playing, right?
Raymond,
right?
Have questions?
So that's what that is. So now what we can do is we see that this is at about 99.5 megahertz. So what we can do now is we can set this to RF. We can turn both of these on. Turn the pilot on for stereo modulation. So let's make this a non-stereo thing real quick, so we're like no longer tuned to a station, right?
3. That's 877.
Okay. Now we're not tuned to a station. So I'll just leave it on that for a minute. We're going to set this right here to 99-ish. You hear that? Check that out, folks. So the frequency generator is working. So that's kind of cool. If we turn the speakers off, we see that we've got a sine wave right there. and it's shaky, I guess, but it's still a sine wave. We can tune off of that, and we'll see we've got other stuff. If we tune back to it, we see that we can actually tune to a stereo signal on this thing. Then I'll flip this light off. You'll see the stereo go away. Turn it back on. Stereo's back. And if we kind of go this way, well, it goes away. But if we follow it, yeah, we can catch it. So there it is. So that is how this FM frequency, I don't know, is SG165 AM FM stereo analyzer works in one way. This is one thing that it does. Now I'm not about to bore you with me learning how this works any further, but I just thought you'd be interested to see, how this thing comes apart, what's inside, certain things that I replaced, and actually seeing it in action here. And again, I'll read. This is at like just barely 100 megahertz. On the tuner here, we've got just under 100 megahertz. So in X-Ray Tony B's video, he shows much more detailed how you can actually check to make sure this thing is putting out the correct frequencies. Obviously this scope is not going to be very good for measuring exact frequencies. I don't have a frequency counter and I don't have a frequency analyzer, so I'm a little SOL right there, but I work at a place where they do have stuff like that, so I'll take this in to work someday, and on when it's a rainy day and we're not terribly busy, I'll see if we can hook this thing up to one of our good tools at work and make sure it's actually putting out the proper frequencies. Alright folks, that's it for today's video. If you have any questions, leave them in the comments. I'm not sure how many questions I'll be able to answer about this thing right now, but coming soon will be me performing proper FM alignment on this thing. Probably the power washed 2230, and then I've got the 2215B still from the Marantz video, how to restore that, and that definitely needs one. I've also got a 2270 that's, the tuner's just really funky on it. I wonder if this thing can help me dial that in and make it work a little bit better. So yeah, thank you so much for watching. I will see you in the next one.